Hey everyone, in today's video, we're going to be solving the problem add two numbers. So the question says you're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. All right, so this is what the question is. And what does the question say? So if you're given two linked lists, one of the linked lists is 2, 4, 3, and the other one is 5, 6, 4, you need to return a linked list as the output of 2 plus 5, 7, pointing to 4 plus 6, which is 10, and the 0 you can put it over here, and you need to carry the 1 over here, which would be 3 plus 4, 8, right? So you need to return a 708. So if you go down, so if we go down here, so it's a 708, right? So we need to return it like that. Okay, so this is how we need to return it. Cool. Now, how are we going to solve the problem? So before we do solve the problem, I'll also tell you one thing. This might look a bit more confusing, but the question is actually like this: it's 3, 4, 2, and 5, 6, 4. So this is what the question is. It's just return in reverse order, and when you add, this is 7, this is 10, and when you carry this, it would be 8, 807, and you need to create it like this: 7, 0, and 8. So this is how the question is. Okay, so let's say I'll give you one more question like 9, 8, 7, 1, 2, 3, something like this. So if I have like this, it'll be 3 added here, 8 plus 2, 10 plus 1, 11. Add 1 here, 9 plus 1, 10 plus 1, 11. And the output would be something like this: 0, 1, 1, 1. Right. So this is how the question is. Okay. This is how the question is framed. Okay. Now, how are we going to solve the problem? It's actually a very straightforward problem and only has one solution, which is the most optimal solution. So let's walk through how the problem is, and how we're going to solve it. Okay. So what we're going to do is we're going to keep two pointers. One pointer would be here, L1, and one would be here, L2, right? Or let me just rub all of this and create it again. Where is my eraser? Yeah. Yeah. Okay. So 2, 4, 3, 5, 6, 4. Right. So let's keep two pointers. Let's keep L1 and L2 as my two pointers over here. Right. And also, what we'll do is we'll create a dummy node. Right. We'll create a dummy node 0. And now what we'll do is we're going to check the values. Firstly, we'll add the two values. We'll add L1.data and L2.data. Right. On adding them, we'll see what we'll get. We'll get a 7. Right. We get a 7 over here for this value. We'll append the 7 over here like this to the next of the dummy node, right? Next, what we'll go is we'll move forward, we'll increment, we'll go from L1 to L1 dot next, and L2 to L2 dot next, right? When we go over here, we see that a 6 and 4 will give me a 10, right? Give me 10, which is basically a carry of 1 and a node value which would be 0, right? My node value would be 0 and my carry would be 1. So I would just append my node value over here and move forward by incrementing L1 and L2, which will go to the next. Now, when we go to the next, we'll see that we have a value of 3 and we have a value of 4. Right now, my L1 was here. Now it goes to here, right? Okay, so right now we're here. So now when we add 3 plus 4, we get a 7. And now we have to add the carry also. So we get a node value of 8 and the carry gets completed because there's no carry remaining. So we'll get 0, right? And we'll append 8 like this. Okay, so this is how we're going to solve the problem. Okay, now what are we doing with the carry? Okay, so what is happening with the carry, right? So when we dry run the code, firstly, what we're doing is, let me rub this again. So when we're dry running the code, right, what we're doing is, first of all, we're declaring a list node 0, which is our dummy node, basically. We're just declaring that. And now what we're doing is we're giving two pointers equal to list 1, which would be my first list, and L2 equal to list 2, which would be my second list. right? The head of the first list and the second head of the second list. And now what am I doing is I'm checking. I'll keep my carry value equal to zero. Currently, at the start, it would be zero, right? Currently, at the start, my carry value would be zero. And what I'll do now is I'll run a loop. I'll run a loop from while L1 or L2 or carry. Okay, now you understand why we didn't carry as well. Now, when we have a while L1, L2, or carry, right? So, while L1 or L2, right? So, we both have L1 and we both have L2, and carry is zero, but it doesn't matter, right? Since we have a value in L1 and L2, we'll just move forward. What we'll do is we'll add, we'll keep a sum value equal to zero, right? Let me just, write it over here at this corner like this. We'll keep a sum value equal to zero, and this is all inside the loop. Okay, we'll keep a sum value of zero, and we'll add the sum. We'll add the sum value of L1 and L2, right? So what we'll do is we'll add sum plus equal L1 dot data. We'll do L1 dot data plus L2 dot data, right? We'll add the sum value of L1 dot data and L2 dot data, right? On adding the sum value, right now my sum would have a value of 7 in the very first case. So let me write in a red pen over here. My s would have a value. Initially it would be 0. Now it would have a value of 7, right? Now it would have a value of 7. Now before moving on to the next one, right? Or also you could do one more thing, or actually this is also still fine. Or actually, you know what, let's try it in a more concise way so that it's more understandable. What we'll do is, because I just forgot one edge case, that if either of them is going to get completed first, let's say this is just like one node, two, and I have five, six, and four, right? So I would get an error in the case I wrote earlier, because one of them could be null, right? So just to avoid that case, what we'll do is we'll write if list one, or sorry, L1, if L1 is present. So what we can do is sum plus equal L1 dot data, and we'll do L1 equal to L1 dot next, right? Second step is the same thing for L2. If L2 is present, sum plus equal L2 dot data, and we'll do L2 equal to L2 dot next. Perfect. Now, in the next step, so, okay, yeah. So now what we have done is we added the value of sum like this, 7, right, from L1 and L2. We go inside the loop, we initialize sum equal to 0. We check if sum L1 is present. If L1 is present, we add the value of L1 to s, which will be 2, and then we check if L2 is present, and we add the value of L2 to s, which will be 5. 2 plus 5 is 7, and then we increment the counters. So we move from L1 here, now L2 is here, right? Now what we'll do is, before creating the node that gets connected to DN, what we'll do, we'll check with carry. Right now carry has no value present, right? So what we'll do is, and I think you also understand what carry would be. Carry is going to be, let me just write in a different pen, let's write with green. Carry is going to be the quotient, or whatever the spelling is, quotient, quotient of the number by 10. Right. So if I divide the number by 10, whatever the quotient is, that would be my C. That would be my carry. So in this case, what would my carry be? Let me just change this here. So what would my carry be? In this case, if I do a C equal to 0 slash 10, that would just give me a carry of again 0. It won't make any changes to it. So what I would do, I would just come here and write my C equal to s slash 10, and later Below, I'll just create my list node, which would be uh, dn dot next equal to list node. And what would I add in the list node? I would add in the list node, I would add uh, basically the output, right? So my output right now is 7, right? So I'll add 7 over there, but I won't directly add 7. I'll add the remainder of, so I'll write it like this. I'll write s as percent 10, which is basically going to give me the remainder, right? So 7 divided by 10 is going to give me the remainder of 7. And right, and why do we do this is just so that, if my number goes above, let's say if I have a 4 plus 6, which would be 10, right? It would give me a value of 10, which is greater than 9, right? You have two numbers, 1 and 0 in present inside that. If I do s percent 10, that would give me a remainder of 0, which would be the node present, right? Exactly. That's what we want, right? This would be the node what we want present inside the linked list. This would be 0, and we would want to carry 1 over there. And when we go to C over here, what would C be? C would basically be s slash slash 10. That is basically the quotient. So what would 10 uh 10 divided by 10 and give me the quotient? That would be 1. So that would be my carry, which I add over here, right? So that would basically be it. Okay, so I would write it like this. Let me just go down here, and I would just write it like this as percent 10, and I would make dn equal to dn dot next. Perfect. And in the very last, when I finish my loop over here, let's say out of the loop, when the while loop is completed, I'll just return dn dot next. And why am I returning dn dot next? Because we already created a dummy node at the start called 0, and we're appending all the nodes to a dummy from that dummy node 0 to and connecting the next nodes from it. So we'll just return dn dot next. So let's do a dry run of what's happening. So we already reached at this point, right? We had a 7, right? So when we had a 7 over here, my carry would have been 0 at this point. So let me just write it over here. I'll write it over here. My carry would have been 7. Sorry, in a different pen. Carry would have been 0, and my sum was 7. So when initially I had a node of 0, right, and I'm going to connect my list node dn dot next. Currently my dn is here. My dn dot next would become a list node of 7, right? S percent 10 would just give me a remainder, which is s modulus 10 would just give me a remainder, which is going to be 7. So I'll just append that. Right. Now we make dn over here, which is dn is equal to dn dot next. Right. Now we move up. Right. So at this point, my list one, L1 is at 4 and my L2 is at 6. And now my L1 and L2 are present, right? They're not null, and carry is 0. So but still L1 and L2 present if we don't need to worry about carry. So what we're going to do now is we're going to move forward. We're going to see L1 is here, L2 is here. Now L1 is equal to sum plus list of data. So now again, this is going to be 0. So this is 0. And let me just rub this also. Right. Yeah. So this is 0. Now I add my list L1 dot data over here. What is my L1 dot data? It's 4. So I add 4 over here. I move my pointer of L1 to L1 dot next. So let's move the pointer. So this is done. So we have L1 over here. Next thing, I check for L if L2 is present, L2 is present, then sum plus equal L2 dot data. So I append and make this equal to a 10, right? And I move my pointer. I move the pointer from L2 over here, right? My L2 pointer goes over there. Now the next step is check for the carry, if a carry is present or not. If I find the quotient of this, so s double slash 10. So if I do that, what would that be? So 10 divided by 10 is going to give me a quotient of 1. My carry gets updated to a 1 over here. Perfect. Now, and I append dn dot next, my next node of dn, with my list node of s modulo 10, which is going to give me a remainder of 0. Right. So it give me a remainder of 0. So append over here with a 0 node present. Perfect. Now let's move on. This time And this time my dn also gets updated to this point. Dn is equal to dn dot next. Perfect. Now let's move on. Right now, when my L1 here, my L1 is present, L2 is present, and carry is also not 0 this time. Carry is a 1, right? So carry is also present. So now what we're going to do is we're going to reinitialize S equal to 0. S is equal to 0. Now, if L1 is present, what we're going to do, we'll add 3 to it because L1 dot data is 3. So we'll add 3 and we'll just move L over here, right? So L is now equal to none. Perfect. Now, if L2 is present, if L2 is present, we'll just append L2 dot data, which is 4. So this becomes 7, right? And we'll move L2 to L2 dot next like this, and L2 is becomes none, right? So this is complete. This is completed. Perfect. Now let's move on to the next one. What do we see in terms of carry? Okay. Now since we have a carry present, one thing I didn't do over here, I'll just write it right now. We'll just add s equal to s plus equal to sorry s plus equal to c. Right. What s plus equal to c would give me is right now my s is equal to 7. Right. Now I add the value of carry present in it. That would give me a value of 8. Right. That would give me a value of 8. And then I would just check my value 8 with what would my remainder, what would my quotient be? Right. With s double slash 10. What would my quotient be in this case? Right. It would be a 0. So my carry gets updated to a 0 again. Right. And we move and we make the next pointer of dn equal to list node s percent 10, which is equal to 8, right? And then I move my dn to dn dot next. Perfect. So this is what the code is, guys. Okay, so this is what the code is, guys, and we move to dn equal to dn dot next. Perfect. Now I'll just tell you why the carry is also present in this case. Everything is none now. L is none, L2 is none, carry is equal to 0. So we'll stop the loop, we'll come out of the loop, and in the end we'll just return dn dot next. In the end, we actually won't return dn dot next. What we'll do is here we'll create a cur value as well. Dn is equal to cur is equal to list node, and return cur dot next because right now my dn is at this point and my cur would be here, right? And we would return cur dot next, which would give me the node 702. Perfect. So this is what the output would be, guys. This is what the code would be, and this is what the output of the code would be as well. Now, one more thing. Why have I written carry over here? What does carry do? I'll just explain what carry does in a small code, let's say. So let's say if I have let's do it on the next page. Okay, previous new page. Yeah, let's say if I have a single node, let's say I have a single node 9 and a single node 9. Perfect. Now, what would this do? This is L1, this is L2, right? What would happen over here is I would create a cur value equal to dn equal to list node of 0, right? So I created a node 0 pointing to something. Perfect. Not, pointing to none actually, right? In this point. Right. Now what am I doing in the while loop? Now my L1 and L2, you already know the code, right? L1 is equal to list 1, L2 is equal to list 2. Now we go inside the while loop, while L1 or L2 or carry, right? And carry is equal to 0. Right, we're going inside this. Now what we're doing, we're checking if L1 is present, then sum plus equal, and we're initializing sum here, s plus equal L1 dot data, right? If L2 present, s plus equal L2 dot data, right? And we're moving L1 equal to L1 dot next, and L2 equal to L2 dot next, right? After doing this, let's go here. After doing this, what we're doing is after coming out of this if statement, we're c adding s plus equal to c, s plus equal to c is equal to s slash slash 10, and then s is equal to and dn dot next. Was this right? Yeah, dn dot next is equal to list node Yeah, dn.next is equal to list node of s% 10, s modulo 10. And then we just do a dn equal to dn.next. Perfect. So this is what basically the main code was, right? So let's say if you have a 9 and 9 present over here, right? If I add a 9 over here, let's say my carry initially is 0, my sum is getting 0 when I come inside the loop. If L1 is present, add it over here, 9. Perfect. If L2 is equal to, if L2 is present, add 9. So this will become 18 in total. Right. So it becomes 18. I add my sum with carry. Nothing is present in carry, so we won't add anything. Now, C would be equal to, what would C be equal to? Right. So what is 18? What is 18 divided by 10's quotient? That is, what is it? It's 1, right? So your carry gets updated to 1 in this point, right? So your carry gets updated to 1. Your carry gets updated to 1. And then you move and check what the value of S is. Your S would be equal to S% 10, which we don't need to write, but yeah, this would be equal to S% 10. And we just append that to the list node, right? So we just append S% 10 as a new list node, which would be 0, which has a dn pointing to 8, right? 8 would be the remainder of 18 divided by 10. So we'd append that. We just connect that with the dn node and we increment dn over here, and our curve would be here. Perfect. Now what's happening is now we have a curve value present equal to 1, and our sum would be equal to 0. But our list 1 and list 2 are equal to none. Right? This is equal to none. List 2 is equal to none. Right, both of them would be none because they both added these values and they just did L1.next and L2.next and they went to the none stage, none point basically. But we still have a carry present. And you also know that if 9 plus 9 is equal to 18, it's not just 8, right? We need to add a one more node, 8 pointing to 1, right? And we have a carry of 1 present. So if carry is not none, we'll also still again go inside the whole process of the loop. This case, we won't do the if statements L1 and L2 because they both are none. But what we do is we'll just add S to C like this. We just add S to C, and then we just make S the quotient of 1 divided by 10, which would be 0. Right. So we make C again 0, and we just add S% 10, which would be 1. So we add a node like this 1, increment dn over here, and in the last stage we just return cur.next. Cur.next, where cur would be here and the dot next, and cur.next would give me 8 pointing to 1 like this as our output. That is why we do cur as well. We take carry inside the as a parameter in the while loop as well. All right. So this is what the code is, guys, and the time complexity of the code is O of n, because we're going to loop through the whole uh, you know of the whole list. It's going to actually just be the greater between the length of list 1 and list 2. So the time complexity is actually not n, is actually, it is O of n, but it's going to be the max between len of list 1 and len of list 2, whichever is greater. That would be my time complexity, which eventually just turns out to be O of n because we're just performing one loop. And the space complexity is, I think, I'm not sure. I think it's, if it is going to be O of n if we are required to create a new, if it is given the question that you're required to create a new complete whole list, right, which we are doing, right? So that would give me a time complexity of O of n. But just one more thing, if it's not mentioned anything like I mean, it is mentioned, right? You have to anyways create a new complete list, right? So you can assume it to be O of 1. You don't need to create assume it to be O of n because it is given that you need to create a new list from scratch. So it is going to be O of n eventually, but because it is anyways given that you have to create a list, so we don't need to really assume it. We can just assume it to be O of 1 because we're not doing anything extra besides the exception of creating that list, which we have to do anyways, right? Okay, so this is what the question is, guys. Let's just see what the code looks like. So this is what the code looks like, guys. Let me just run the code over right now. Yeah, the code is running, and let's submit it. Yeah, it is submitted, guys. So that's all for today's video, guys. If you like the video, do like, share, and subscribe. Do let me know in the comments if I could do better teach the concepts to you guys in any way. Also, there's a 10% coupon code for Geeks for Geeks below. You can for a course, you can just check it out. And do check out my podcast as well. We have some amazing speakers over there who've talked about multiple topics. So I'm guessing that will help you out as well a lot. And until next time, guys, thanks for watching.